I want to start with a minor detail. Not a grand conspiracy, not a world-shattering revelation, just a simple note in the margins. The kind of detail you would normally scroll past, but once you connect it to everything else, you can no longer unsee it. I was going through digitized forestry archives from the 1860s, specifically botanical records from Eastern Europe, looking for something completely unrelated. But as I scrolled through hundreds of pages of timber estimates, I stumbled upon a handwritten note in the margins of a forestry report. It was penned in an elegant, hurried script, using faded iron gall ink. It mentioned trees in the Bielo-Isar region producing fruit in unnaturally synchronized cycles, and described root systems that, in the surveyor's own words, appeared to communicate purpose. The surveyor, a Polish-born forestry commissioner working under Imperial Russian land surveys in 1863, seemed genuinely frightened. He described how the forest seemed to react to human presence, altering the moisture levels of the soil and producing edible nuts in patterns that could not be explained by seasonal changes alone. The rest of the page was torn away, as if someone had hastily ripped it from the ledger before it could be officially filed. But 6 months later, in a completely different archive, in a different country and written in a different language, I found another note. It was nearly a word-for-word match. 2 documents, 2 continents, the exact same phrase. And the deeper I looked, the more of these anomalies I began to find. What I found points toward something that keeps appearing at the very edges of our official history. Places where the trees are older than the stories we have been told. Places where species coexist against all ecological rules, and where growth patterns look less like wild wilderness and more like a carefully engineered, deliberate system built long ago for human benefit. Food forests, still self-sustaining, still producing, just not for us anymore. And the strangest part? The people who know about these places have gone to extraordinary lengths to ensure you never visit them, transforming these ancient agricultural infrastructures into high-security nature reserves under the guise of ecological protection. Between roughly 1850 and 1910, across North America, Europe, parts of Asia, and the Pacific, there was a sweepingly synchronized movement to reclassify land. Forests that had previously been documented in local records as abundant sources of food, ancient orchards with no known planting history, and commons where people gathered produce that nobody planted and nobody owned. All of these places were suddenly fenced off, renamed nature reserves or national parks, and declared off-limits for conservation purposes. But we have to ask ourselves, conservation of what? And from whom? The official narrative tells us this was the noble birth of environmentalism, a reaction to industrialization. We are taught to praise early conservationists who argued that nature must be kept pristine, untouched by human hands. But why did this transition happen so abruptly? In 1 decade, the land sustains the people, providing a natural buffer against dependence. In the next, it is fenced, guarded by armed rangers, and the records of its abundance quietly vanish from the official archives. What exactly was being secured here? Consider Yosemite Valley in California. When Western explorers entered the valley, they praised its pristine, untouched wilderness. They saw majestic, open meadows and groves of towering California black oaks. But this landscape was far from untouched. For generations, the indigenous Ahwahnee people had actively cultivated this valley, planting black oak acorns and using highly controlled, seasonal burning to prevent pests, clear underbrush, and maximize crop yields of hazelnuts and medicinal plants. It was a vast, open-air food forest, a highly productive, human-designed ecosystem. Yet, under the guise of fortress conservation, the indigenous stewards were violently evicted, and their traditional agricultural practices were strictly banned. In the name of protecting nature, the state severed the connection between the people and the land. Almost immediately, the health of Yosemite began to deteriorate. Without the ancestral caretakers, the meadows grew overgrown, the black oak groves began to decay, and the forests grew dense with deadwood, fueling the catastrophic wildfires we see today. The official narrative calls Yosemite a victory for wilderness. But in reality, it was the erasure of an ancient agricultural legacy. Let us look closely at Bielo-Isar. Sitting on the border of Poland and Belarus, it is the last and largest remnant of the primeval forest that once stretched across the European plain. Today, it is UNESCO protected and heavily restricted. Large interior zones are completely inaccessible to the public, open only to credentialed researchers under strict supervision. But even they are not allowed everywhere. There are vast regions within Bielo-Isar that have never been officially surveyed by any public scientific institution. We have mapped Mars and the ocean floor in detail, yet we lack a public topographic survey of sections of a forest in the middle of highly developed, modern Europe. This explanation begins to falter when you open old maps of Tartaria, specifically those published in Amsterdam and Paris during the 17th and 18th centuries. If you draw a line along the western boundary of the territories labeled Tartaria Magna, it lands with striking precision on the borders of the Bialowieza forest. Furthermore, on these very maps, the spaces within those boundaries are frequently filled with detailed, stylized illustrations of trees. Not mountains, not cities, but dense, structured forests. What were the cartographers marking? The deeper you go into the botanical literature of the region, the more anomalies you find. Bialowieza contains species assemblages that have no clear evolutionary pathway in this climate. According to modern models of post-glacial reforestation, these plants simply should not coexist in the same ecosystem. Even the European bison was described by 19th-century locals not as a wild animal, but as a creature living in a managed, symbiotic relationship with the land. It is as if the entire forest, along with its inhabitants, was once a single, artificial system. Who managed it? And does it, in some sense, still manage itself today? Another immense piece of this puzzle lies in South America, within the Amazon basin. For over a century, explorers and botanists have stumbled upon mysterious, incredibly fertile patches of dark earth scattered throughout the rainforest, known as terra preta. Unlike the surrounding tropical soils, which are notoriously thin and nutrient-poor, terra preta is rich in charcoal, calcium, phosphorus, and microbial life. It retains nutrients for thousands of years, resisting the heavy tropical rains. It is a soil that literally grows and regenerates itself over time. Modern science admits that terra preta is anthropogenic, meaning it was manufactured by an advanced, pre-Columbian civilization. But the implications are far wider. Wherever terra preta is found, the forest changes. The trees grow taller, and the species mix shifts dramatically toward fruit-bearing and nut-bearing varieties. The Amazon is not a wild, primordial jungle, it is a continental-scale, ancient orchard. A massive, self-sustaining food forest engineered by a highly advanced population that inhabited the basin millennia ago. And yet, just like Yosemite, the vast majority of these areas are either designated as inaccessible reserves, restricted national parks, or are being systematically deforested. The incredible, self-renewing technology of terra preta remains largely unstudied by mainstream agriculture. Let us travel east, to the island of Yakushima in southern Japan. It is famous for its ancient cedars, the yakusugi. Some of them are thousands of years old, and the most famous giant, the Jomonsugi, is conservatively estimated to be anywhere between 2,170 and 7,200 years old. That massive gap in dating is not a typo. Researchers admit that the internal structure of these trees defies standard tree ring analysis. The growth rings do not behave the way rings are supposed to. But there is something else that is impossible to ignore. These giants do not grow randomly. Ecological surveys show that the trees are distributed in a pattern that perfectly mirrors a complex, multi-tiered food forest. The oldest trees sit at the centers of radiating zones of decreasing age, spreading outward from a point of origin like waves. Yet, the Jomon period, which gives the oldest cedar its name, is officially classified as a pre-agricultural society of hunter-gatherers. How do we reconcile nomadic, primitive tribes with a forest system that looks like the product of advanced, long-term ecological engineering designed to produce food for millennia? Not far from Yakushima lies another anomaly, Akigahara, the sea of trees at the base of Mount Fuji. Growing on a 9th-century lava flow rich in iron, the forest is famous for its physical anomalies. Compasses spin uselessly, GPS signals degrade, and electronic equipment behaves unpredictably. While the magnetic properties of the volcanic rock are real, historical records suggest something far more significant than a mere geological quirk. In pre-modern Japanese sources, Akigahara was described as a place of immense supernatural importance. Today, modern media has completely rewritten this narrative, framing it with grim, sensationalized lore that successfully distracts the public eye from the forest's true, ancient significance. This brings us to a place where the pattern is hardest to deny, Bouvet Island. Located in the subantarctic, it is the most remote, uninhabited island on Earth. There is no permanent population, no harbors, and no obvious resources. It is a sheer volcanic rock capped by glacier, battered by the most violent winds on the planet. Yet, in 1928, Norway claimed it, officially annexing it in 1930, and has quietly maintained that claim ever since at considerable diplomatic and logistical expense. Why? The secret lies beneath the glacial ice. In the coastal margins where the ice retreats, researchers have discovered ancient, highly resilient vegetation. Moss communities and botanical specimens grow there in structured, geometric patterns that defy the harsh, random conditions of that latitude. Public access to the island is virtually non-existent. Expeditions are strictly controlled by the government, and the full findings are conspicuously absent from any public archives. It is yet another closed zone, keeping a silent watch over ancient life and physical anomalies that officially should not exist. When we put these pieces together, we are left with what can only be called a coordination problem. Within a brief 50-year window, rival nations with entirely different political systems, the Russian Empire, Meiji Japan, and the United States, all took identical steps to seal off and reclassify these specific types of land. If these places are not merely wild nature, but the remnants of a highly sophisticated, global infrastructure of abundance left behind by a past civilization, then the entire concept of conservation must be viewed in a new light. It suggests a coordinated effort to hide the ruins of a beautifully designed biological garden. By telling the public that these places are wild, natural, and untouched, governments prevent anyone from asking who designed them, how they work, and what they were capable of producing. It keeps us dependent on centralized food systems, while the keys to absolute self-sufficiency are locked away behind the fences of national parks. The most critical question is not about the past at all. It is about the present. Is this system still running? Are these root networks still communicating purpose, coordinating cycles across hundreds of acres beneath our feet? And if so, what are these fences and park rangers really protecting? Are they protecting the forest from us, or are they protecting us from what the forest might tell us?